Welcome to your first week and your first lesson in Net 225, the culminating course in the Cisco CCNA sequence. And the course is based on the Cisco Networking Academy's course entitled Enterprise Networking, Security, and Automation. You'll, of course, find the materials on the Networking Academy, where you will see the main course modules, which should be familiar to you. And each of those module units, let's call them, are broken down into the content, and then there's a clickable link for the exams. There's not an exam for every single chapter, as you may be familiar from a past course. Some of the material is grouped together in multi-chapter modules. In the very first week and first chapter of this course, we will be looking at a very important protocol called OSPF, and it happens to be in a group that we call link state routing protocols. So let's just take a little minute to review a little bit about what is a link state routing protocol. In past iterations of this course, in fact, back in time, if we go into the Wayback Machine, there was a protocol called RIP, Routing Information Protocol, and it was a distance vector protocol. It was a big part of the Cisco CCNA series, and a big part of networking in small to medium size businesses. Now, why the change? Why the transformation away from RIP? Well, these distance vector models basically were low overhead and required not a great deal of computing resource. And as you may be very aware, computers have come a long way in the last 10, 15 years. They've come from larger desktop computers to laptops, tablets, and powerful computing processing in our phones. Well, the same things happen with routers. A router is nothing more than a special purpose computer. So with these distance vector protocols, the only thing that the router really knew about was this thing called the distance or metric that was required to reach the ultimate destination network, and then which path or interface was going to get you there. So you can see it is likened to traffic signs, where you really don't know much about your trip until you get to the sign and it's pointing toward the city to which you would like to go, and then you just make the decision and trust that you are being put on the way. there is a whole collection of protocols that are in a category called interior gateway protocols. So the distance vector protocols do fall within that umbrella, but there is another kind of protocol called link state. And link state protocols build an entire map, a complete view or topology of the network by doing a lot of data collection at the get-go to build this overall map. So it is more like your GPS, the ultimate goal being that every router in your area of concern has all of the information about the entire topology. And each router creates this topological map, which is really just lots of units of data that virtualize that network. And then they are able to independently calculate the shortest path to every other destination that might be in the area. So link state protocols, again, are likened to your GPS that has all of the landmark and road information built in, and it is able to map out the best path to whatever destination you choose by referencing all of that collected information. Another interesting thing about link state protocols is that they do not operate on periodic updates. Once they reach a state of calm, we might say, they are converged, in other words, that the only reason that updates are sent is when some topology change is detected. A link comes up, a link goes down, a new link is installed into the network, or an entire new router is put into production. That is when the protocol sends out updates, and then a new period of sharing the information must take place. Link state protocols are sometimes also known as shortest path first protocols, and the protocol, in fact, that we're going to learn about in this class is OSPF, Open Shortest Path First, and it is built around a mathematical algorithm that was developed by Edgar Dijkstra. And that name definitely is referenced in your Cisco materials, so I would keep that name in mind. In general, link state protocols have, a reputation of being more complex than the counterparts in the distance vector category. But most of that complexity is hidden from you and me. It's built into the processing that's in the router, and the router is nothing more than a computer. All link state protocols are really built around 3 building blocks, and we can see them here. And these really are the fundamental building blocks of information and computing technologies. If you think about it, around today's modern computers with everything networked, we have messages, which we could think of as data in motion, a way to exchange information between nodes or entities. Data structures, which are frameworks to save the data, either in random access or volatile memory, or at rest in storage. And processing or algorithms, the logic that is used to massage and manipulate our information along the way. So every link state protocol, and a protocol is just another, fancy name for software. You'll find as you study computing in different courses that you'll find all these different names for software. You'll find daemons when you talk about Linux, and services. Well, protocols or routing protocols are just another type of software that manages, manipulates, processes information. So those 3 components, messages, data structures, and algorithms, keep that in mind, because those will be also important as you study this chapter. So let's take a look back at the material that you'll be reading. And the core of your study will start in unit 1.1.1, where we have the introduction to OSPF, or Open Shortest Path First. You'll find out that there is an OSPF version 2 and an OSPF version 3. It's just the version that deals with IP version 4 and IPv6. The primary focus at the beginning is going to be on single area OSPF v2, so in the IPv4 world. We're going to read about those 3 basic building blocks: the messages, the data structures, and the algorithms. And I suggest that you click each one of these items in the material and make sure that you understand that there are these 5 different message types: the hello packet, the database description packet, something called the link state request packet, an update packet, and an acknowledgement. Then you'll read about the data structures, which are mainly tables, which are then built into databases that talk about the network in terms of neighbors of each router, how the routers are formed in the network, So the link state database represents the network topology. And remember also to keep this in mind, the link state database is often just referred to as LSDB. So that's just the acronym for link state database. But you'll often see in the reading LSDB, and you're going to be expected to know what that means. So the acronyms are important to recognize. And then there's this third structure, the forwarding database, which is created from the routing table, and it lists all the routes generated when the Dijkstra algorithm is run on the LSDB, and you can see or view what has been generated with one of the router show commands. So that is something else that you should really pay attention to in the reading. Each of these show commands, you will be using these as you deal with labs throughout this chapter and mainly in chapter 2. Single area OSPF is discussed. A little bit of information on multi-area OSPF, although you will not be stressed on that quite yet. Remember to do all of the checks as you work through the material. It should be very familiar to you, the look and feel of the course. It's based on the Cisco Networking Academy basic structure, which you have seen in previous courses. There are videos built in. I always recommend that you watch them. It packages a lot of useful information into short bites. So you'll see that there are just 4 subdivisions in the first chapter: 1.1, 1.2, 1.3, and 1.4, which is just really a quiz on what you had learned so far. Again, pay attention to these various acronyms, because sometimes you're going to see them without their spelled out counterparts, and you'll be expected to understand their meanings. First week, not a lot of stressful material, time to get your feet wet, sort of get used to what's going on, and after that, we'll just really hit the ground running. So you're going to learn a lot in this class, and you will most definitely be prepared at the end of this class to take the industry certification, the CCNA exam. There are some practice exams built into the course. If you do have the goal of taking the CCNA cert exam, I highly recommend those practice exams, and you're almost there. So let's have a good semester.